Hi, I'm Bob Kelko with Apex Data Solutions, and welcome to our Phase 2 presentation for the NAII AI Tech Sprint. This demo is intended to provide a quick update on our team's progress preparing for the final demo in April, and as a brief primer on our use case. My role as Chief Architect and Lead Developer at Apex. Marianne Carlton and Brandy Ray are also part of our public-facing team on this sprint. For subject matter experts, making sure we get this right, we are honored to have Dr. Jorge Ferrer from the U.S. Department of Veterans Affairs and Dr. Roger Boudou from the U.S. Department of Defense. Before we proceed, I just want to give a very high-level overview of our use case, which is tackling the well-known industry problem of provider directory. It affects literally everyone across our healthcare system, whether directly or indirectly, and veterans now more than ever with the recent establishment of the VA Choice Program, making external providers accessible to veterans who require specialized or urgent care not available at the VA. In the interest of time, I'm not going to read the following several slides verbatim, but I'll summarize them as we go. So feel free, since this is a recorded demo, to pause and read the content at your leisure, including the endnotes at the end, which are referenced throughout. Let me kick off the demo environment so it's spun up by the time we are ready. Okay, great. Okay, so why is this an important use case? For Americans generally and veterans especially, easy access to healthcare professionals is considered a right based on the assumption that the information about them is always accurate and up to date. Unfortunately, in practice, this premise is all too often incorrect, and it's particularly incorrect with regard to the state of provider directories, both private and public. The healthcare industry suffers a chronic failure in keeping directories of providers accurate and up to date, and it costs the industry, consumers, and government dearly every year. These costs manifest themselves in many ways, not the least of which being an immense administrative burden, particularly considering the process of updating this information is neither uniform across the payers, nor is it particularly modern. Payers feel bombarded by diverse lines of business across the multiple payers with whom they have professional relationships. On average, there's around 20.2 of these relationships in terms of contracts, and each of them demanding that the provider update their information all the time. There are a number of data points spread out across the payer contracts, and these add up to a lot of data, some 8,400 data points, that can get misaligned across all these systems at any given point in time. Compound that with the diverse payer requirements for reporting, and as you can see, the struggle is real, and with it, a massive collective recurring headache of compliance verification. Inaccurate provider data hurts everyone, but for providers, the costs are quite painful. Literally a full staff day per week, costing on average around $1,000 a month. Per practice, the fully loaded annualized costs actually average up to $63,004 a year. Extrapolated nationwide, this amounts to a staggering $2.76 billion sinkhole annually. This is money that could have been used or gone to covering lower costs or provide actual patient care. So as you can see, it's a huge opportunity cost, to put it diplomatically. To make things even more urgent for the industry, Congress recently passed the No Surprises Act, which will impose more complex requirements and stiffer penalties for failing to solve this problem. In a nutshell, it means that both payers and providers need to be able to prove compliance through mandatory regular auditing. Given how chaotic the current process is, this is a daunting challenge. In summary, the problem is twofold: ensure that key data elements are always up to date at all times, and be able to prove it on a variety of diverse verification frequencies. So a near real-time solution with full audit-ready transparency is desperately needed. And that, in a nutshell, is what we're working on. So this sprint for us is the first in what will be a series of sprints and pilots to see if a real-time mechanism for solving the problem is feasible from first principles. The first principle is, given a single source of truth, is there a non-obtrusive way to bring diverse systems of record, or SORs as we'll refer to them, into information alignment? Meaning that they have at any given point in time the same basic information regardless of database-specific nuances or application-specific requirements. A novel use of blockchain is employed for this purpose, untethered from the distributed ledger metaphor that complicates other efforts to leverage blockchain in healthcare. Our approach differs from other ongoing efforts to define system of record APIs and to get these systems of record to quote-unquote talk to each other, so to speak. In short, it's architectural in nature, not API transactional. And that means that each SOR does not need to know about, much less communicate directly with, any other SOR. That's a big deal. This is the second principle, that interop should be part of the woodwork of things, a part of a normal enterprise architecture, most definitely not point-to-point. Another hidden benefit of this approach is that given industry investment in big data, it provides many logical entry points where AI technology and techniques can be introduced to solve domain-specific problems. Sprint's narrowly scoped, but it's still fairly ambitious. It's composed of about 8 steps. We are going to mock out a payer environment emulating a master database and the databases of 2 separate lines of business, namely TRICARE and VA Choice. For the purpose of our demo, that's what we'll call them. These will be on different database stacks, as is the case in the real world. We're going to populate these with an initially small amount of data, around 100 providers. These are real providers borrowed from a well-known payer's public-facing provider directory, but they're used fictitiously here to illustrate the problems. We're going to emulate batch updates to illustrate the current woefully inadequate process typically followed by modern payers to align their line of business databases with their master database. And from the point of view of where we're at right now, this is where we are. So we're going to show you that environment. The next steps will be to translate the domain to an interoperable format using RDF, and HL7 is a good foundation for starting that process. We're going to create linked data adapters on top of each of the systems of record using our Apex Olympus linked data microservices platform. These will be designed to conform to a protocol for change propagation defined by our interoperability solution, Apex Unify. The goal is to see the changes from the providers that are added to master and watch them propagate near real time to the lines of business databases that care about them. Multiple places here where AI could add value, and we'll point those out. Blockchain is used again to build a single source of truth with time travel capability, meaning you can go back in time at any point and see the state of the universe. Data alignment without batch scripts, providing full compliance auditability is the objective. All right, so let's show you what we got so far, where we're going by the end of the sprint, and where we think this can go long term. Basically, we have emulated the data infrastructure of a small payer servicing both TRICARE and VA Choice programs. We use different databases because it's quite common in the industry. Mergers, acquisitions, and varying popular frameworks du jour over the years mean that the same information is contained in wildly diverse data and technology stacks, and this is the heart of the interop problem. All right, let's kick off the master update. So the state of the universe that we want to begin with is going to show that the master is going to be out of sync with the line of business. But let me give you this visual so you can kind of anticipate what you're going to see. Now, basically, we have 3 databases, one of which is considered master, and it contains all the data in Postgres. We have 2 lines of business representing TRICARE and VA Choice. TRICARE is in a SQL database, but it's a different SQL, in this case MySQL. And VA Choice we've done in MongoDB, which is a popular NoSQL alternative. We did this to establish the critical data interoperability barrier of different database stacks, and this introduces a layer of incidental complexity on top of the domain. Or rather, it would be incidental complexity if it wasn't also the first technical obstacle to our desired solution. So we tackle that head on in this sprint. We did not, in this iteration, vary the UX or the data loading emulation in the interest of time, but subsequent sprints will see us adding additional layers of complexity, such as different application stack or security, network configurations, etc. In this pass, we're content to keep as much of that kind of stuff the same as possible so that we can get the data plumbing in place first, so to speak. All right, I have a cheat sheet here of providers we're going to be looking up. Let me move this out of the way for a moment, and let's take a look at the environment. All right, so we have a nice little portal here. So we have the payer master database has a web interface, a REST API. We have a TRICARE, which has a web interface and a REST API, etc. We're going to take a look at the web API here. And what we've done so far is we've implemented the changes in the master database, but not yet in the line of business. So what we're going to see is there's some interesting changes to a few select providers. Let's look at Eugene DeLucia first. Okay, so you can see there's data about him. This is representative of what you would see in a normal provider directory. In this case, we know he's in the choice plan, but not the TRICARE plan. So let's open up the choice plan real quick and look for him there. All right, we can see he's there, but we do have some differences. Okay, so there are some things have changed. So we see that the VA choice is out of alignment, and I won't get into detail because we got an interest of time. We also have Colin Moore, who is in the master. He is in master and TRICARE, so we'll open up TRICARE and find him. All right, and so we can see that there are some differences, and therefore this is out of alignment. We have one character here, ready, that is in all three. So we will show you that real quick. Okay, so that you can see here again, the information has changed in master, but it's not reflected in the other two. And they have basically the same info, even though it's a slight presentation difference. Okay. All right. So what we need to do now is we're going to run the update on. Hold on one second. We're going to run the update on TRICARE, which is MySQL. And what we're going to see is then that the TRICARE will come into alignment with the master data, in as much as they have the same things in common. Some deleted providers that do not exist while that's running, I'll show you one. So we should not find Nelson Castellano anymore here, and we do not. But Nelson Castellano does exist in the choice plan. So we'll go over to choice and prove that it hasn't been deleted yet while that's running. And sure enough, okay. And we also have the same with Giovanni Williams. I'm not going to go through all of these just to save time. Okay. All right. So now we want to see for TRICARE. Let's try to find one of the deleteds. TRICARE is Giovanni. Okay. Okay, so we see that TRICARE is now in alignment with that. Let's go back to Delucia, or let's go back to Ready. And I'm going to kick off while we're talking. I'm going to kick off the VA one. So now we're going to run the batch update on. We're going to run the match update on that while we are looking at this. So we've got Sunil Ready, and we're going to go look for Ready here again. And we'll see now that TRICARE is in alignment, okay? And as soon as that is done running, which will be in a moment, we'll be able to verify that as well for VA Choice. Okay, let's go back to home and find Ready again. And we can see now that Ready is in alignment. Okay, so that's a good case because we can see now that all three have been brought into alignment, but we also see that the process has been through batch scripts, and that's what we want to get away from. So let's take a look back at our architecture diagram. This is where we want to be. By the end of the sprint, we hope to emulate something like what you see in this diagram. There's no batch scripts involved. Everything is in real-time change propagation. In this use case, we're modeling a single payer's internal infrastructure, but notice that there's this little line from ForeverDB transactor. That's where you could conceivably cross boundaries of organizations. And that might look something like this in the future. You can imagine CMS, VA, and DoD all sort of sharing provider directory information in this fashion, each one with their own copy, each one managing their SORs, but a change to any of them updates all of them. That's where we want to go. Like John Lennon said, it isn't hard if you try to imagine this. It can happen. So the key points here are that this is an architectural approach. We use blockchain to create a source of truth. External alignment goes through distributed transactor. We use linked data as the inter part of interop, and Unifi's architecture provides the op part. And there are several really cool entry points in the architecture where it can add value, where AI can add value, and we're going to be going over those in subsequent demo. But we are getting short on time, so if you have any questions about this presentation, please don't hesitate to whisk them off to our project manager, Marianne Carlton. And here are the endnotes we promised earlier. Feel free to pause and check them out if you want to verify our research. And finally, let me just close by saying thank you for your time, and we hope this was helpful.